So remote laboratories, we've got 20 slides to whiz through in the Petricucci thing. We'll whiz through them. Remote laboratories. So last year we gave you a bit more of an in-depth talk on student experience. This year I wanted to talk about the sustainability piece, because I think that's a really difficult thing to do, to take an idea and start scaling it up. So next slide. So what we've got is a cloud system that connects real hardware to students who operate in the browser. We've got over 100 experiments now, and we're serving classes as large as 450. Next slide. So we've got these spread across campus and all sorts of locations. So we're turning the place into a science museum, which is fabulous. Next slide. And this year we've prepared a booking system that allows us to pre-book things to students, allows students to book in advance, and allows them to cancel. And that's really helpful because the pressure on the system has increased now that we've got more users, and having that kind of control is very helpful. So if you just scroll down a tiny bit on that one, you can see this is a pre-book session. You give a student a link and they go into their classroom. It's not a specific laboratory space. There's another student there they can work with. They've got staff member walking around, or staff members walking around, so they get that peer-to-peer interaction, they get that peer-staff interaction, and they're doing practical work, and we pre-booked them on one piece of equipment for an hour, and then on the other piece of equipment for an hour. Okay, next one. And just to have a quick look at an example of an experiment. If you just scroll right down the bottom, we've got a little motor on a little weight on a motor. Scroll down a bit more. We'll go through more pages. Okay, so this is a good model of an arm on a robot. And if you want to control a robot arm, it's pretty important that, let's say you've got a robot that's trying to lift a cup of coffee to your mouth. You wouldn't want it to go too far and hit your teeth. You wouldn't want it to not get far enough and tip it down your front. And you wouldn't want it to do any other sorts of ridiculous things that an arm might do if it wasn't as well trained as the arms that we use are. So moving on to the next slide. So we can take students through setting up a control system that's a little bit slow maybe, but it's very safe, gets to where it needs to go, doesn't go anywhere else, but it takes its time. An alternative is one that gets there a little bit faster, but it then comes back again and eventually settles in the right place. Moving on to the next slide, thanks, Abby. What students can't do in the real world is take a system all the way into an instability. And this is a little bit ironic because often the methods for designing the system say, right, go and make it unstable and figure out how rapidly it oscillates when it's unstable, and then use that number to design a system that never does this. Of course, if you do it once, you break the system and there's no point in designing a control system. So we, with our environment, are able to let students explore things that they wouldn't do in industry, but that are important for understanding why you wouldn't do it. They can take our experiment, make it unstable, and it's entirely and utterly safe. And they get to see the advantage of doing that method to learn about how to design the controller, and then they get to do it without doing that step and see the difference and see how in real life you have to take other considerations into account. Right, next slide, please. So what are we trying to do? We're trying to prepare graduates for the grand reveal. Just roll down slightly. Global teams. So, the world is distributed now. The next thing we're trying to do, next slide, is we're trying to prepare institutions for, and the grand reveal, the future, and students, of course. So, funnily enough, we, as I'm sure anybody who's involved in learning tech, are looking at a number of changes that are happening outside universities and thinking that there's an awful lot of change that's coming our way, and that it's a pretty exciting time. Next slide. So while we're looking at this change, one of the important things is that online is complementing. We're not replacing in person. Universities have been accreting layers of technology upon layers of technology for many years now. After all of the invention of the printing press, i.e. a new technology, was enough to replace all of the previously used technologies, we wouldn't still be lecturing today. Because originally the intent of the lecture was, well, we've got this book, we can only write books by handwriting them, so one person says some stuff and the other people write it down, and it's effectively copying en masse. Well, we still have lecturing despite the printing press, so we will still have in-person despite online. Next slide, please. Obviously, external influences have come across our bows recently. 1994 really was the start of the warning, the internet, and I think that was when I was doing my undergraduate in the early era of the internet, and it was the beginning of the end of universities as sort of a hidden monastery or library that no one could get into unless they were doing a degree. Now we have 30 years later AI coming along and making an even bolder claim to being able to tell somebody what they need to know. So do we ban it or embrace it? Well, in my view, obviously we need to embrace it. And Mike Sharples has done some nice work here on actually splitting this into 4 different categories. But ultimately, we need to be embracing these things. I will scroll down for speeds. So one of the things that we're going to need to cope with is that artificial intelligence really hammers our ability to measure end product without knowing whether the end product came from AI. But if we have digitally mediated activities, we've got a rich data stream. And if you scroll down to the bottom of that slide, the grand reveal is that it makes it cost effective to assess process. Because at the moment it's expensive to hand in an essay and mark it, but if we've got digitally mediated activities, it's inexpensive to check in on student progress. And then the usage of large language models and so on is much more likely to correspond to things that would be professionally relevant, and we must embed literacies such as AI literacy in the study that people are actually studying rather than treating them as standalones. So we can't just ban it and then teach someone about it in an hour-long seminar. Next slide, please, Apple. So before the pandemic, co-authors and I were already writing about the idea of collaborating with technology so that we get something that's greater than the sum of the parts and not bound by the limits of either. So there's quite a sort of knee-jerk reaction to technology. So you're going to replace this thing. But actually what we want to do is we want to co-develop. And that's one of the issues with EdTech. If you buy a shiny thing off a shelf and you don't have any role in its specification or its development, then it's really hard to co-develop pedagogy with it. You just get a tool and then you kind of have to figure out how to use it. It's like being given a hammer and then told that you have to unscrew a screw somewhere. Whereas it would be much better to be involved in the workshop that was making the hammer and having a look at the tools that you were trying to develop interfaces to, the screws, the nails, and influencing what's created. So I think there's a much stronger role that we can play, not just in building tools, but also working to specify them so that we can co-develop rather than just having to deal with what we've been able to buy in. Next slide, please, Apple. So a free and public digital infrastructure effectively is a human right, according to a report from April last year in the Human Rights Council. It's a very interesting approach. Suggests that a lot of framing of us as passive receivers of digital technology that we pay for will need to be looked at if we're going to continue to find ways to add value. So it's an exciting time. Next slide, please. So on the sustainability piece, David Reed's been continuing to investigate feedback on students. We've got some very exciting results, which I'll be able to share once they're published. Next slide. I have a new student who's looking at hybridizing simulations with the real world to increase the exploration that students can do. Next slide, please. And I have a position open at the moment for a PhD student with an electronics focus. So if you know anyone who's potentially interested, that does cover international fees. So that's an exciting opportunity for someone. So do fire them my way, please. And also in terms of sustainability, the school has invested in 2 half-time posts to cover mechanical and electrical design, which is why we have the, the wonderful experiments that we've got on the hardware side. And next slide. And also this week, I provided my first formal quotes from another university for the supply of some experiments. So hopefully we're on the road to growing and building that sustainability for this new digital tool, which is being developed in academia so that we can co-develop the teaching and the pedagogy together. And that's the last slide, other than some acknowledgements of the huge number of people that have come together behind this activity. To all of them, much thanks and gratitude for the roles that they play, both big and small. And thank you to the audience.